find an unknown value. Before we talk about what proportions are, let's talk about equivalent fractions.
To see what I mean, let's start with the simple fraction, 1 over 2 or 1/2.
Now let's look at a pair of equivalent fractions, 1 over 2 and 5 over 10.
These fractions are equivalent because even though they have different top and bottom numbers, they have the same value. 1 is half of 2 and 5 is half of 10. So they represent the same amount.
Okay, but to understand what a proportion is, we need to start with a ratio instead.
A ratio is basically just a fraction that's used in a certain way. So let's imagine that a student who's really good at drawing can draw one picture in 2 hours. We could say that the ratio of picture to hours is 1 over 2. One picture per 2 hours. Alright, but what if our student draw pictures at the same rate for 10 hours? How many pictures would they draw? Well, if they finish one picture every 2 hours, then in 10 hours, they'll have drawn 5 pictures. So that ratio would be 5 pictures per 10 hours.
Ah, do you see what we have here? Those are equivalent ratios.
Just like the equivalent fractions, they represent the same amount, so we can put an equal sign between them. When we do that, we have a proportion. A proportion is just 2 ratios that are equivalent or equal. Oh, and one thing that's really important to remember. In order for 2 ratios to be equivalent, they not only have to have the same value, they also have to have the same units.
That is, they have to be representing the same thing on the top and bottom. Let me show you what I mean.
This is a proportion because the top numbers both refer to pictures and the bottom numbers both refer to hours. But what if we change the top unit of the second ratio to be books instead of pictures? 5 books in 10 hours is not equivalent to 1 picture in 2 hours. So even though the numbers are still the same, this is no longer a proportion. Or what if we keep the same units and just switch them in the second ratio so that the hours are on the top and pictures on the bottom? Are they still equivalent? Nope, this is not a proportion anymore. 5 hours per 10 pictures is not equivalent to 1 picture per 2 hours. So the units have to be exactly the same for both ratios to form a proportion.
Alright then, so a proportion is a pair of equivalent ratios.
But why do we care? What are proportions good for? Well, proportions are really good for figuring out something you don't know from something you do know, and that makes them very useful. For example, let's suppose that our baker gets a bulk order and need to adjust the recipe, and they want to know how much flours do they need to complete the order. How do we figure it out? Let me show you. Well, let's start with what we do know. We know that they need 2 cups of flour to make 12 cookies. So let's take that ratio and set up an equivalent ratio for the bulk order, 36 cookies. The key in setting up that equivalent ratio is to make sure that the units are the same as the first ratio. Cups of flour on the top and cookies on the bottom. We know that the number of cookies that they need to bake is 36, so that goes on the bottom. But the number of flour it would take is unknown, so instead of putting a number there, we're going to put the letter N there to stand for the number that we don't know. This is how you usually see and use proportions in math. 3 of the proportions numbers will be known and 1 will be unknown. For 2 net we If you know 3 of the numbers, you can find the missing number easily using a procedure called cross multiplying. Cross multiplying is just a shortcut way of doing some basic algebra to rearrange our proportion so we can find the unknown number. To do it, we first start by writing down a new equal sign because cross multiplying will give us another equation. Next, imagine that the Christmas shape is overlaid on the proportion. This cross shape tells you which numbers to multiply together on each side of the new equal sign. 2 and 36 will be multiplied together on one side of the equation. And 12 and n will be multiplied together on the other side of the equation. Oh, and as long as you follow the crisscross guides, it doesn't matter which pair goes on which side.
Okay, so our proportion has been rearranged. Now what?
Well, on one side of the new equation, we have 2 numbers being multiplied together. The next step is to go ahead and simplify by doing that multiplication. 2 times 36 equals 72. But what about the other side of the equation? That has the number being multiplied by our unknown letter n. How can we multiply when one of the numbers is unknown? Actually, we can't. Fortunately, we don't need to because we're just trying to figure out what our unknown number is. In other words, we need to keep rearranging our equation until the unknown value is all by itself on the one side of the equal sign, and all of the known values have all been combined on the other side of the equal sign. Then we have found the unknown. So let's go ahead and simplify by doing the division. 72 divided by 12 equals 6. And look, our equation is now n equals 6. Now we have figured out what the missing number of proportion is. If our baker needs 2 cups of flour to make 12 cookies, then they need 6 cups of flour to make 36 cookies. We have used a proportion to solve for an unknown. Alright, so in this video, we've learned that a proportion is a pair of equivalent ratios, and we learned how we can set up a proportion that has an unknown number, and then find out what that number is by cross-multiplying. Proportions are really important. If you understand how they work, you can use them to solve all sorts of real-world math problems. For example, estimate the distance between one city to another city using scale drawing. Make a travel plan and estimate how much time do we need to travel from one location to the destination. And adjusting medicine dosage based on weight. Or even we also can use it in business life to estimate how much raw material do we need to complete all the order and plan a purchasing schedule. And the best way to understand them is to practice what you have learned in this video by working some problems on your own.
Thanks for watching my videos, and I'll see you next time.